Let's do this problem right here. The question is asking the length and width of a cardboard are 20 feet and 16 feet. We are going to cut out the corners and fold up the sides to form a box. Determine the height of the box that will give maximum volume. So in this case, what we have to do, first of all, let's create the equation for this one, volume equation. So basically the volume equation is going to be width time length time height for a box. The volume is width time length time height. So we have the width 16 minus 2h, 16 minus 2h, and the length is given 20 minus 2h, 20 minus 2h, and the height is going to be the h, right? H is the height. That's what we have to find. And from this one I can simplify by multiplying everything. So first of all, let's multiply this one by h. So if I multiply this one by h, I will get 16h minus 2h square. So 16h minus 2h square, and here we have 20 minus 2h. And if I multiply these two together, so let's see what happens. 16h times 20 is going to be 320h. 320h, and 16h times 2h is going to be 32h square. That's going to be negative because negative 2h, negative 32h square, and we have minus 2h square here. So if I multiply this one by 20, it's going to be minus 40h square, minus 40h square, and minus 2h square times minus 2h is going to be plus 4h cubed. Since we have 2h square right here, I can add them together. So this is going to be 320h minus 72h square plus 4h cubed. Now I can rearrange this one into from the highest power to lowest power. So this is going to be 4h cubed minus 72h square plus 320h, and this is the quadratic formula. It's the not quadratic, it's the volume equation, right? Now we have to find the maximum height. What I have to do is I have to find the derivative of this one and set that one equal to 0. We have to find the critical points. That's the main thing. So let's do this one. So if I find the derivative of this one, this is going to be 12h square, and then we have 72h square. So if I take the derivative, this is going to be minus 144h. Then here we have 320h. If I take the derivative, it will become 320. Then I can divide everything by 4. If I divide this, so I'm setting this one equal to 0, because then only we can find the critical points. And this is going to be 12h square minus 144h plus 320. And if I divide everything by 4, let's see what happens. If I divide this one by 4, this is going to become 3h square, and 144 divided by 4 is going to be, so 144, right? 144 divided by 4. Let's see. 4 is going to be 3, 12, 24, so 36. So 144 divided by 4 is 36 h, and 320 divided by 4 is going to be 80. And this is equal to 0. And if you see, it's not easily factorable. We can't find a we can't directly factor this one. Therefore, we have to use the quadratic formula. So in this case, b is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So here we have b minus 36, so I can apply this one here. So minus 36 plus or minus b square is going to be minus 36 square minus 4 times a is 3 and c is going to be 80 divided by 2a. 2 times a is going to be 3. And minus 36 becomes plus 36, plus or minus 36 square. So square of 36, 1296. 1296 minus 80 times 3 is going to be 240. 240 times 4 is going to be 480, 960. So 960 divided by 6 and 36 plus or minus 1296 minus 960, it comes out to be 336. 336 divided by 6. And if I calculate this value, there are two possibilities. One is going to be plus or minus. One is going to be plus, one is going to be minus. Let's find both values. So 36 plus or minus square root of 336 comes out to be 18.33 over 6. And if I calculate these values, one of them is going to be 9.055 and the other one will be, so this is one of the value, and the other one is going to be 2.945. So these are the two values I will get if I calculate these values. So in this case, what we can do is find the domain of this one, whether to see whether this is within the domain. So to find the domain, what I can do is I can grab this length and the width and set it equal to, like, you know, the length can't be a negative value. It should be greater than 0. It can't be 0. It should be greater than 0. Therefore, if I set this one into greater than 0 equation, so 20 minus 2h should be greater than 0. Therefore, I can say 2h is less than 20. Therefore, h is less than 10. And also I can use the other one to create a formula. That's 16 minus 2h is greater than 0. Therefore 16 is equal to greater than 2h. Therefore h is greater than h is less than, so 2h is less than 16 and 8 is less than h. H is less than 8, right? That's how it reads. So h is less than 8. So our maximum should be 8. We can't go over it, because if we go over it, what's going to happen is we are going to get a negative value. For example, if you plug 9 here, 16 minus 2 times 9 is going to be 18. 16 minus 18 is minus 2. You can't get a negative value for the dimension, therefore it's not possible. So our maximum is 8 and minimum is 0. So from this one, I know that my domain is going to be 0 to 8. 0 to 8. Therefore, we can eliminate one of these values because we got 9.055 and 2.945. 9.055 is not possible because it's above the domain. So we can eliminate this one, and then 2.945. Now I have to check whether this is the absolute maximum, because we want the maximum. The question is asking to determine the height of the box that will give the maximum volume. So to check this one, I had to check, this is a critical point, and we have to check the endpoints too. So we have to apply this one in the equation and see what's the value we are getting. So if I apply 0 in this equation, if I apply 0 in the first derivative, I have to apply I have to apply this one in the main equation. So if I apply this one in this one, what's going to happen? 0 all will become 0, therefore the volume will become 0. And if I apply 8, what's going to happen? 8 cube is going to be, and if you calculate, the whole thing will become 0. And also if you calculate 2.95, that's going to give you a value, that's the absolute maximum, right? Therefore we know this is the, and you can check it with this one. Now this is going to be a positive value because 320 times h is a big number, and that's going to give you a positive value. Therefore we know for sure that's this is the height that's going to create the absolute maximum volume. So that's the final answer. I hope you guys like this video. See you next time.